This is 8.6 polygons in the coordinate plane. A polygon is a shape with straight sides and is closed. So anything that has a rounded side is automatically not a polygon, and anything that is open is also not a polygon. We have ordered pairs, which are presented in parentheses with an x, comma, y. X is always first, y is always second. And these can represent vertices, which are corners, of polygons. To draw the polygons, we're going to plot their vertices and then connect around the edges. So the vertices of a quadrilateral are A, B, C, and D here, and we're going to draw the quadrilateral in the coordinate plane. So here I have it, and we set it up in a way that I know all of the points are going to fit on here. So I look for what is the largest y and what is the largest x. And I make sure that my coordinate plane fits that. And then I put these down. A would be -2, 2. So since this is x and this is y, we're going to go to the left 2 and then up 2. B is 0, 5, so that's to the side, 0, up to 5. C is 4, 3, so that's to the right, 4, up 3. And D is 3, -2, so that's to the right to +3 and down to -2. And then we just connect around the edges, and we see here we have a four-sided figure, which is a quadrilateral. We have another figure that we are going to plot with these vertices. And what kind of shape is it? A trick to know what kind of shape, how many sides it's going to have, is based on how many vertices it has. So it has 1, 2, 3, 4, 5 vertices, and I know that the vertices is going to match the number of sides. So since it has 5 vertices, it's going to have 5 sides, so it should be a pentagon. What type of pentagon? We don't know yet. So when I put these on the coordinate plane, I didn't include the left side of the coordinate plane because I didn't have any negative x's. So I knew I didn't need that. If you are unsure, you can always make a standard size coordinate plane, and then you can extend it when needed. So when I put 1, 2, 3, 4, 4, 0, 2, -1, and 3, -2, and then connect them, I can see it kind of looks like an upside-down house, which is a pentagon. We can also use these on the coordinate plane to find the distances between the points. So we can find the distances between points in a coordinate plane with the same x or the same y by using the absolute values of the coordinates that are different. So if I have 2, 7 and 2, 4, the x's are the same because they're both 2, and I can find the distance between 7 and 4. So 7 minus 4 is 3, and so these are going to be 3 units away. Here's an example. We're going to find the distance between A and B and A and C. So here I have points A, B, and C here in blue, and they each cross over an axis. So when they cross over an axis, I'm going to use the absolute values to find the distance between that point and the axis, and then the axis and the second point. So here, since this is -2, this has an absolute value of -2. And then I take the absolute value of 3 and add those together. So I would find that these are 5 units. You could also count and say 1, 2, 3, 4, 5, and do that. And then from A to C, A to the x-axis is 3 units, absolute value of 3. And then from the x-axis down to C at -1, this is the absolute value of -1, which when I add them together would be 4 units.